Okay, so now that we've introduced ourselves to some special right triangle situations, let me just go ahead and do some problems that are a little bit outside the box to get you ready for some homework problems or things that you'll see in the future. So here, what we begin with is we have a nice 45-45 triangle. So we know from our pattern that these two sides have to be the same and that this side has to equal x square roots of 2. Alright, and so that basically gets the ball rolling. So we basically have to find x. Well, there's my equation, right? So if this side's 10, that means 10 is equal to x square roots of 2. So if we divide both sides by the square root of 2, what we get is that x is 10 square roots of 2. So we pretty much have found x. The only problem is what we've learned earlier, we usually don't like radicals down the denominator. So to rationalize this, I'll multiply both top and bottom by the square root of 2. That gives us 10 square roots of 2. On the bottom we get the square root of 4, and so we're left with 2. And of course 2 into 10 goes in 5 times, so we're left with 5 square roots of 2. So that's kind of a crazy situation, alright, with regard to that, because we're used to seeing the square root of 2 on that side, but the math just works out that way. So kind of crazy. So that problem, right, 5 square roots of 2 is what the other two sides are equal to. Alright, so another situation that kind of is a crazy mind bender is over here. We have another 30, 60, 90. Of course, what we know about the relationship is the side opposite 30 is x. That's the guy that determines everybody else. That side will always be 2x, and then this side would have to be x square roots of 3. So since this side is equal to 12, that means that 12 must equal x square roots of 3. So if I divide both sides by the square root of 3, we get an x value of 12 square roots of 3. But again, we have the situation where we don't like radicals down the denominator, so I'll rationalize it and get 12 square roots of 3 all over the square root of 9, which is 12 square roots of 3 all over 3, which is 4 square roots of 3. So what we have here then is that x is equal to 4 square roots of 3. So that means that this is 4 square roots of 3, right? That's what that side will be. This side will be 2 times whatever x is. So this would be 8 square roots of 3. So again, pretty crazy. I think the reason being is that these sides already are a nice neat number. So we usually want, they'll involve a square root of 2 or square root of 3, but the sides are already nice and neat and they kind of canceled out really well. So kind of a unique situation. I just want you guys to be prepared for it if you see those in your homework set, which I believe you will. Alright, and so here's another oddball. I think there's a word problem kind of associated with this somewhere in that homework set, if I'm not mistaken. But whoa, right, we got all kinds of things going on, and I have a lot of sides, right? I don't know what this side is, I don't know what that side is, I don't know what that side is, and I don't know what that side is. So I have 4 things I do not know. So how about we break it down and kind of just forget about that for a moment, right? As far as we're concerned, this is a 60-degree angle, which makes this a 30-degree angle, and so we know the sides, right? This side over here is x, and this side over here is 2x, and this side over here is x square roots of 3. So if we can at least solve this one, we can get 2 of our sides, and then we'll go worry about the next one. So let's worry what we can. So the square root of 75, well, that breaks down into 5 times 3, which becomes 5 square roots of 3. So that basically tells us, right, if we divided both sides by the square root of 3, our x has to be 5. So that means that this side has to be 5, and that means this side has to be 2 times 5, which is 10. So we now know that that side's 10. So of our 4 sides, we've got 2 just by using our 30, 60, 90. So now let's forget about this situation and look what's happening up here. What's happening up there is I have a 45-degree angle. I'm indicating that this is a 90-degree angle, so that means that this has to be a 45-degree angle, which means that this side, right, has to be the same as this side, and that this side is x square roots of 2. So we're off to the races. So if this side is 10, that means this side is 10, and that means that this side has to be 10 square roots of 2. So what looked like a very daunting problem actually turned out very easy because we had patterns within patterns. So that side's 5, that side's 10, this side's 10, and that side's 10 squared roots of 2 because of our special patterns. So just look at it, break it down into pieces. You guys can do it. All right, one more application to look at. I'll see you in the next video.